Hello guys, in this video we'll be learning about an example of VTC curve and finding all its nominal voltages. First, let us take an example of an inverter. This is the symbol of inverter. This device produces a high output when the input is low and produces a low output when the input is high. So this is the given data. They have given NML, which is the noise margin low, and NMH, which is the noise margin high, which is equal to 0.5 volts. We need to find all the nominal voltages. Nominal voltages in the sense that we need to find VOL, VIL, VOH and VIH. First, let us look into the graph which they have given. Okay, this is the graph which they have given, and we need to compare this graph with our original VTC graph. So we need to compare this graph with the original VTC graph. Both the graph looks similar. Okay, let's observe the graph now. Inverter produces a valid digital 0 whenever input is a valid digital 1. We know that. So lowest output voltage produced by the device, we choose VOL to be at least 0.4 volts. By comparing both the graphs, we get VOL as 0.5 volts by taking legal digital 0 into the consideration. Inverter produces a valid digital 0 whenever its input is a valid digital 1. So looking at the VTC, the output will be less than or equal to VOL, which is 0.5 volts. So let's set VIH as 3 volts. So we got VOL, which is 0.5 volts, and VIH, which is 3 volts. So we have two data. So we have VOL, which is 0.5 volts, and VIH, which is 3 volts. So now to find the other two nominal voltages, that is VIL and VOH, we take the help of NML, the noise margin low, and NMH, the noise margin high. We know that VOH is equals to VIH plus NMH. From NMH is equals to VOH minus VIH. The same way, VIL is equals to VOL plus NML. From NML is equals to VOL minus VIL. By calculating that, we get VIL, which is equal to 1 volts, VOH, which is equals to 3.5 volts. We have VOL, which is 0.5 volts, and we have VIH, which is 3 volts. The actual VTC looks like this. You can see that this is VIH, which is 3 volts. This is VOL, which is 0.5 volts, X and Y coordinate. I hope you understand this. VIL, which is 1 volt. As you can see that this is 1 volt. And VOH, which is 3.5 volts, 3 to 4, 3.5 volts. So the data and the nominal voltages will be VOL, which is equal to 0.5 volts, VIL, which is equal to 1 volt, VOH, which is equal to 3.5 volts, and VIH, which is equal to 3 volts. In conclusion, if we have sequence like this, 0 less than VOL, less than VIL, less than VIH, less than VOH, less than VDD, the voltage supply, satisfying this constraint guarantees that the outputs produced are better in quality than inputs. Thank you.